For example number 7, and I'm just going to throw the textbook up here so you guys can read along with me and see. People always say, well, when am I going to use this in the real world, blah, 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 blah. Well, on your test next week. That's my favorite response. But no, this is really used in the real world. So, for example number 7, they want us to predict the maximum revenue. So, they say to use the model y equals negative 15,358.93x plus 73,622.5 from example number 3 to develop a model for a weekly revenue generated by donut-shaped oat breakfast cereal sales. Determine the maximum revenue and how to achieve it. Okay, so what we're going to do is we're going to look at the solution, and then I'll write it all down and I'll explain it. But I want to kind of model for you guys how to use your textbook. So the revenue can be found by multiplying the price per box by the number of boxes sold. So the revenue is x times y. If you multiply that out, you'll get a quadratic equation. Notice over here to the left, if you graph that quadratic equation, the maximum value is equal to whatever the vertex of the quadratic equation's parabola is. So all that stuff we did in example number 5 with regards to finding the maximum mathematically, I mean our calculator will do it automatically, but we could do it mathematically just by using the terms given here. And so let's do that. So the first thing, and if you guys don't remember, in example number 3, we had some equations. So the first equation that we looked at was, well, first of all, we modeled the revenue. We had this equation. We had y is equal to negative 15,000.3893x plus 73,622.5. So this equation was, we graphed how many boxes or how many boxes people would buy depending on the price and the number of boxes and all that stuff. So what they wanted us to do was to find the maximum revenue, right? So we're going to predict the maximum revenue. Well, what does the x represent? Well, the x represented the number of boxes, right? So this represented a model that helped us to understand what the revenue was. The more boxes we sold, and all that stuff. And so to predict the maximum revenue, we're just going to take x and multiply it by y. Well, y is equal to all this stuff, so we're just going to say x times negative 15,358.93 x plus 73,622.5. When you push that through, you get negative 15,358.93 x squared plus 73,622.5 times x. Okay. And what does that represent? Well, we said that the revenue can be multiplied by finding the price per box x. So this y represents the revenue, or actually it's the number of boxes sold. So this was the number of boxes sold. And x represented the price per box. And so before I move any further with the mathematics, I get a little gung-ho because I know what we're doing, but this is the practical application. In example number 3 we went through, and we said, and just kind of a refresher, I think you guys will need to understand what we're trying to do. In example number 3, what we did is we said if we increase the price of a box of cereal, then we'll sell less boxes, right? And so what we found is as the price gradually increased, the number of boxes we sold decreased. And we went through and we graphically displayed the data, and we wrote this equation. This is a linear equation to help us predict how many boxes we would sell. Okay? Well, X was the price of the box. So as the price increased, we would sell less boxes, because as the price increased in dollar value, we had to multiply that by this negative 15,000. All right? And so, and let me show you the chart of where that linear equation came from. In example number 3, so we'll zoom in so you guys can kind of wrap your head around. Now this is the kind of thing that you need to take your time when you go to do your homework at home, because so many times we just start plugging away and trying to find the answer and we don't understand what we're trying to do. So example number 3, they gave us the price per box, and then notice that the number of boxes that we sold, as the price increased, the number of boxes we sold decreased. And so in example number 3, we were asked to model that behavior. And so we, at the end of example number 3, what we discovered is that if X was the price per box, we would expect to sell Y number of boxes based on this equation. So to find our maximum revenue, what we want to do is we want to figure out what's the best price to sell it at. So we need an equation that involves the price per box and the number of boxes. So the maximum revenue would occur when we have the price per box and the number of boxes we sell. So to figure out how much money we would make, or the revenue that we would generate, we would take the price per box and multiply it by the number of boxes, and that's how we end up with this quadratic equation, right? So we say that the revenue is equal to this equation. So the maximum occurs, now if you look at this, this is going to be a quadratic equation that turns upside down. So the maximum value is going to occur at the vertex. So we're going to have something like this, and this vertex is the maximum Y value, or the maximum value. I shouldn't say Y, but X here is going to be the number of boxes sold, and Y is going to be the revenue that we generate. And so the maximum value occurs at the vertex. And so now that we know how to find the vertex, it's not that hard to do. We could do it in our calculator, but we could do it by hand by using this, because we know that the vertex is H comma K. We know that H is equal to negative B over 2 times A. Or negative, what's the B term? It's big, 73,622.5 all over 2 times A, which is negative 15, comma 358.93. And so if we plug that in our calculator, we're going to get this really huge number. So let's do it. So if I plug in my calculator, negative 73,622.50 divided by, and then we'll start parentheses, 2 times negative 15,358.93, close my parentheses. What is that telling us? I think I may have misspoke. This is not the number of boxes, this is the price per box. So if I wanted to generate the maximum revenue, what would I charge per box? $2.39. Okay. Well, how many boxes would I sell? Well, in order to find that out, what I'd have to do is I'd have to take my revenue and say negative 15, comma 358.93, and then say 239. I'm just going to say 2.4 squared plus 73, comma 622.50 times 2.4. Okay. So now let's enter that in our calculator. So let me just show you this on the screen. What am I trying to find? Well, we said that the h was 2.4, right? That's the vertex. Now I've got to find the corresponding k. And I find that by plugging the 2.4 into the equation. So I'm going to need to plug that into my calculator. And I get negative 15, 358.93 times 2.4 squared plus 73622.5 times 2.4. Now what that's telling me is I should bring in $88,226.56. Okay? Now how can I verify all that math that I've done? So what did we just figure out? We figured out that we can make an equation that represented how many boxes I would sell if I changed the price of an item. And that equation was this one here. So this represents the number of boxes I would sell based on the price of the per box. But then to find my maximum revenue, what I realized is I needed to figure out the price of the box times the number of boxes. Well, when I write that out symbolically, I get a quadratic equation, and the maximum value occurs at the vertex of this parabola. Using the fancy math that Mr. Adams has taught me, I found that I can find the vertex of this parabola by a simple equation, negative b over 2a. And that gives me the corresponding value of h. Then to find k, I simply take that h value and plug it into my quadratic equation. Now if I wanted to verify this, I could simply just plug in the quadratic equation into my calculator and then let the calculator find the maximum value for me. So I'm going to plug into my equation negative 15,358.93 times x squared plus 73,622.5 times x. Graph it. Now it's going to look really goofy, so I'm going to have to change my window. Now how would I set my window? Well, my h and k is around, my x values is around 2.4. So I'm just going to say x is between 2 and 3. Now, whoops. Now my y value is a pretty big y value, so I'm going to say 85,000 to 90,000. And I'm going to hit graph. Those are some pretty big numbers. Let's check that zoom again. So I went from x is 2 to x max is 3, 85 to 90. Let's change the x scale or the y scale to 5,000, I guess. Oh, it's just not, it's just not showing it. That's weird. So if I plug in 2.4, it's just not showing the graph because the numbers are so big. Did I plug something in wrong? Do you guys see what I did? That's why it's not showing. I said plus instead of times. Alright, so now it should show. There we go. Did you guys see what I did? So now we're just going to calculate the graph's maximum value. So I'm going to go a little bit to the left of the max, which is about right here. And then I'm going to go a little bit to the right of the maximum value, which is here. And then I'm going to go pretty close to what I think it's supposed to be, which is about here. Any questions?